Welcome to where time falls quiet.
Sumer and Egypt weren't first. They rebuilt something older. Take a moment to subscribe, so this place of calm is always here for you. What if everything you know about the beginning of civilization is a carefully constructed lie? Not a deliberate deception, but something far more unsettling. A story we tell ourselves because the truth was lost so completely that even the memory of forgetting it has vanished. What if the cities that rose in Mesopotamia 5,000 years ago weren't humanity's first attempt at civilization, but its second, or its third? What if the invention we celebrate was actually restoration, the rebuilding of something that had already existed, thrived, and then disappeared so thoroughly that when we finally clawed our way back, we had no choice but to call it the beginning? The evidence has always been there, buried in the clay and carved into stone, but we've been trained to look past it. We've been taught that human history follows a clean, upward trajectory, from primitive hunter-gatherers to farmers, from farmers to city builders, from city builders to empire architects. It's a comforting narrative, one that places us at the apex of a steady climb toward progress. But what if that story is wrong? What if the arc of human civilization isn't a straight line at all, but a cycle of rise and collapse, of knowledge gained and then catastrophically lost? What if we're not the pioneers we believe ourselves to be, but the inheritors of something we can barely remember? This isn't speculation rooted in fantasy or fringe theory. This is about looking directly at the evidence that mainstream archaeology has struggled to explain for over a century. It's about taking the anomalies seriously, the uncomfortable data points that don't fit the accepted timeline. It's about asking why the first cities appear already sophisticated, why the earliest writing systems emerge fully formed, why ancient mathematics contains knowledge that shouldn't exist for another 3,000 years. These aren't minor inconsistencies. They're foundational cracks in the story we've built about who we are and where we came from. Consider this. When archaeologists first excavated the ancient Sumerian city of Uruk around 1900, they expected to find evidence of gradual development, the slow evolution from simple villages to complex urban centers. That's how civilization is supposed to work. You start small, you learn, you grow. But that's not what they found. Instead, they uncovered a city that appeared almost overnight in the archaeological record, already equipped with monumental architecture, sophisticated irrigation systems, administrative bureaucracy, and a writing system capable of recording complex transactions. There was no learning curve, no period of experimentation. It was as if someone had simply turned on a switch and civilization began. The Sumerian language itself deepens the mystery. Unlike other ancient languages that can be traced back to earlier forms and related tongues, Sumerian is what linguists call an isolate. It has no known relatives, no clear origin, no linguistic ancestors. It simply appears in the written record fully formed, complete with technical vocabulary for astronomy, mathematics, law, and architecture. This isn't how languages evolve. Languages develop slowly, borrowing from neighbors, adapting to new needs over generations. But Sumerian arrived as if it had been imported wholesale from somewhere else, carrying with it concepts and terminology that suggest a level of sophistication that shouldn't have existed yet. Then there are the mathematical tablets. In 1945, a clay tablet known as Plimpton 322 was analysed in detail, and what researchers found was staggering. This 4,000-year-old document contained a table of Pythagorean triples, numerical relationships that wouldn't be formally described by Greek mathematicians until more than 1,000 years later. But the Sumerians weren't just aware of these relationships. They had systematized them, created tables for calculating them, and used them in practical engineering applications. The tablet wasn't a lucky guess or a mathematical curiosity. It was evidence of a computational system so advanced that modern scholars have compared it to algorithms used in contemporary computer. How does a civilization develop such sophisticated mathematics without leaving behind any trace of the learning process? Where are the crude early attempts, the mistakes, the gradual refinement that should precede mastery? They don't exist. The mathematics appear in the record already perfected, as if the Sumerians inherited a complete system rather than inventing one. This pattern repeats across multiple domains: astronomy, architecture, agriculture, metallurgy. In each case, the earliest examples we have are far too advanced for a society that supposedly just invented these fields. The same impossibility appears in ancient Egypt. The Step Pyramid of Giza, built around 2600 BCE, is traditionally considered Egypt's first major stone structure. But the precision of its construction, the sophistication of its architectural planning, and the engineering knowledge required to build it suggest that it couldn't have been a first attempt. Yet there are no obvious predecessors, no smaller practice pyramids that show the Egyptians learning how to work with stone on such a massive scale. By the time the Great Pyramid of Giza was constructed just over a century later, Egyptian engineering had reached a level of precision that we struggle to match even with modern technology. The tolerances are too tight, the alignments too perfect, the understanding of structural mechanics too complete for a civilization supposedly still in its architectural infancy. This isn't about ancient aliens or supernatural intervention. This is about confronting a much more mundane but equally unsettling possibility: that human civilization is older than we think, that it has risen before and fallen before, and that what we call the birth of civilization in Sumer and Egypt might actually be its resurrection. If that's true, then the knowledge these ancient peoples possessed wasn't invented by them. It was remembered, imperfectly perhaps, incompletely certainly, but remembered nonetheless, passed down through oral tradition, preserved in fragments, carried forward by survivors of a catastrophe so complete that almost everything was lost. The archaeological record hints at this catastrophe. Around 10,800 BCE, the Earth experienced what geologists call the Younger Dryas impact event, a period of rapid climate change triggered by what appears to have been a cosmic collision. Temperatures plummeted, ice sheets advanced, sea levels dropped, and then, just as suddenly, rose again as the ice melted. Coastlines that had been inhabited for millennia were submerged beneath hundreds of feet of water. If there were cities along those ancient shores, they now lie at the bottom of the ocean, buried under sediment and beyond the reach of conventional archaeology. How much of human history is hidden there, waiting to be discovered? If a civilization existed before the flood, if it possessed knowledge that was then transmitted to the survivors who eventually founded Sumer and Egypt, then what we're looking at isn't the beginning of human achievement. It's the preservation of it. The pyramids weren't built because the Egyptians suddenly figured out geometry. They were built because someone still remembered how. The Sumerian King List, with its impossibly long reigns and its clear division between rulers before the flood and rulers after it, wasn't mythology. It was an attempt to preserve historical memory in the only way available, through story and symbol, through numbers that encoded astronomical cycles and calendrical systems. This reframing changes everything. It means that the foundation of our civilization isn't innovation, but recovery. It means that the great leap forward we celebrate might actually be a crawl back from catastrophic loss. And if civilization has collapsed before, completely enough that we forgot it ever existed, then the question isn't whether it could happen again. The question is whether we're prepared for when it does. Every tablet we unearth, every monument we study, every anomaly we document is a message from the past, a warning encoded in stone and clay. The only question is whether we're willing to listen. Imagine holding a piece of clay in your palm, no larger than a modern smartphone, its surface covered in wedge-shaped impressions pressed into the material 4,000 years ago. The tablet is catalogued as Plimpton 322, discovered in the early 1900s in what was once southern Iraq, the heartland of ancient Sumer. At first glance, it appears to be nothing more than an accounting record, the kind of mundane bureaucratic document that fills museum storage rooms by the thousands. But when mathematicians finally decoded what those cuneiform marks actually represented in 1945, they realized they were looking at something that should not exist. This wasn't an accounting ledger, it was a trigonometric table, a systematic list of Pythagorean triples calculated with an understanding of numerical relationships that wouldn't be formally described in the Western world until the Greeks over 1,000 years later. The tablet doesn't contain approximations or lucky guesses. It displays 15 rows of numbers, each representing a precise mathematical relationship between the sides of right triangles. The calculations aren't simple either. They involve complex manipulations of large numbers, requiring an understanding of square roots, reciprocals, and what modern mathematicians call the sexagesimal system, a base 60 numerical framework that the Sumerians used with the same ease we use base 10. To create this table, the scribe who pressed those marks into wet clay needed to understand abstract mathematical principles, possess computational algorithms for deriving these relationships, and have access to a broader mathematical framework that made such calculations practical and useful. This wasn't the work of someone stumbling toward understanding. This was the work of someone operating within an established mathematical tradition. But here's the unsettling part. There's no evidence of how the Sumerians developed this tradition. In mathematics, as in any discipline, you expect to see a progression. You expect early attempts that are crude, refinements that are gradual, mistakes that are instructive. You expect to see the learning process preserved in the archaeological record, the tablets that show scribes working through problems, making errors, developing techniques. Those developmental stages don't exist. The earliest mathematical tablets we have from Sumer are already sophisticated. They contain multiplication tables, division algorithms, and methods for calculating areas and volumes that reveal a mature understanding of mathematical principles. It's as if the entire system appeared already complete, inherited rather than invented. Another tablet, catalogued as YBC 7289, contains a geometric problem that requires calculating the square root of 2 to 6 decimal places. The Sumerian solution, written in cuneiform around 1700 BCE, is accurate to within 1 part in a million. They didn't have calculators. They didn't have computers. They didn't even have the symbolic notation we use today to represent complex operations. Yet somehow, they possessed computational methods precise enough to achieve results that would satisfy a modern engineer. The tablet doesn't explain how this calculation was performed. It simply presents the answer, as if the method were so well understood that it didn't require documentation. This implies that the mathematical knowledge preserved on these tablets represents only the tip of a much larger body of techniques and concepts that have been lost. The sophistication extends beyond pure calculation into practical application. Sumerian architects used these mathematical principles to design irrigation systems, calculate the volume of grain storage facilities, and plan the layout of cities with geometric precision. The ziggurat temples that dominated Sumerian skylines weren't built through trial and error. They were designed using mathematical ratios and proportional relationships that ensured structural stability and aesthetic harmony. The foundations were surveyed with accuracy that required an understanding of angles, distances, and celestial alignments. This level of applied mathematics doesn't emerge spontaneously from a society that's supposedly inventing these concepts for the first time. It requires generations of accumulated knowledge, refined through use and passed down through teaching. The Sumerian mathematical system itself hints at inheritance. Their base 60 numerical framework is far more sophisticated than our base 10 system for certain applications. It allows for elegant division and fractional representation because 60 has many factors: 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This makes calculations involving time, angles, and circular measurements remarkably efficient, which is why we still divide hours into 60 minutes and circles into 360 degrees. But developing such a system requires foresight and understanding of its advantages over simpler alternatives. It's not the kind of numerical framework you stumble upon accidentally. It's the kind of system you design intentionally, or more likely, the kind you inherit from predecessors who had already worked out its mathematical elegance. Consider the implications. If the Sumerians inherited their mathematical knowledge, then someone before them possessed it. Someone understood trigonometry, calculated square roots, and used sexagesimal notation. Someone had a reason to develop these tools, practical applications that required this level of precision. Where did that someone live? What civilization did they build? And what happened to them that their knowledge survived only in fragments, preserved imperfectly by the societies that came after? The clay tablets we study today might not be the original source of this mathematics. They might be copies of copies, transcriptions of older texts that were themselves incomplete records of an even more ancient system. The Babylonians, who inherited much from the Sumerians, took this mathematical tradition and expanded it. Tablet BM 85194, housed in the British Museum, contains algebraic problems that involve solving quadratic equations, systems of equations, and cubic roots. These aren't simple arithmetic exercises. They're abstract mathematical investigations, explorations of numerical relationships for their own sake. The scribes who created these tablets were mathematicians in the truest sense, pursuing knowledge not just for practical applications, but for intellectual understanding. This suggests a culture that valued mathematical inquiry, that supported specialists who could dedicate their lives to numerical study. Such a culture doesn't emerge overnight. It requires institutional support, educational systems, and a long tradition of scholarly work. But perhaps the most revealing aspect of Sumerian mathematics is what it tells us about their understanding of the cosmos. Many of their calculations involve astronomical numbers, the length of lunar months, the cycles of planets, the precession of the equinoxes. They tracked Venus with such precision that modern astronomers have used their observations to date historical events. They understood that celestial movements follow mathematical patterns, that the heavens operate according to calculable rules. This knowledge wasn't simply religious or mythological, it was empirical, based on centuries of careful observation and numerical analysis. To possess such knowledge requires stability, continuity, and the accumulation of data across generations. It requires a civilization that lasted long enough to observe these cycles and sophisticated enough to record them systematically. The numbers themselves become evidence. When you examine the mathematical constants that appear repeatedly in Sumerian texts, certain values stand out. 3,600, 12,960, 43,200. These aren't arbitrary. They're multiples of key astronomical cycles, the periods it takes for celestial bodies to return to the same positions in the sky. The Sumerians encoded vast spans of time in their mathematics, preserving knowledge of cycles that take centuries to complete. Why would a young civilization, supposedly just beginning to develop writing and mathematics, concern itself with calculations spanning thousands of years? The answer becomes clear when you consider that they weren't making predictions. They were recording what had already been observed, preserving measurements that required millennia of continuous observation to obtain. The clay doesn't lie. It can't be edited, can't be revised, can't have its history rewritten. Once those wedge-shaped marks were pressed into the wet surface and the tablet was baked, the information became permanent. What we see in these mathematical records is evidence of knowledge that predates the civilizations that recorded it. The Sumerians weren't inventing mathematics. They were preserving it, transcribing it, keeping it alive through the only means available to them after something was lost. The tablets are messages, instructions, attempts to pass forward, understanding that had almost disappeared. And the message they carry is clear. We have forgotten more than we ever learned. There exists a document that mainstream archaeology treats as mythology, a curiosity to be catalogued and then quietly dismissed. It's called the Sumerian King List, and it's one of the most unsettling texts ever discovered in ancient Mesopotamia. Not because of what it claims, but because of how it claims it. The document is written in the same bureaucratic style used for grain inventories and temple accounts, with the same matter-of-fact tone employed for recording tax revenues and land distributions. It lists rulers, their cities, and the length of their reigns with clinical precision. But here's what makes scholars uncomfortable. The reigns it records before the Great Flood lasted not decades or even centuries, but tens of thousands of years. One king ruled for 43,200 years, another for 36,000. These aren't round numbers meant to convey a very long time. They're specific figures recorded as if they were exact measurements. The text begins with a declaration that should make us pause. After the kingship descended from heaven, the kingship was in Eridug. Not that kingship was invented, not that it began, but that it descended. The language implies transmission, inheritance, something being passed down from elsewhere. Then it lists 8 kings who ruled 5 cities before the deluge, and their combined reigns total 241,200 years. After this section comes a single, devastating line. Then the flood swept over. Following that marker, the document continues listing kings, but now the reigns are different. They're still extraordinarily long by our standards, hundreds or thousands of years, but they're no longer astronomical. The text draws a clear boundary between what came before the catastrophe and what came after, treating both periods as equally historical. For over a century, historians have dismissed these pre-flood reigns as purely mythological, symbolic numbers meant to convey divine authority rather than actual chronology. But that interpretation requires us to ignore something crucial. The Sumerians didn't write mythology the way they wrote history. They had different literary forms for myths, legends, and historical records. The King List is written in the historical style, using the same grammatical structures and organizational principles found in texts that record verifiable historical events. If the pre-flood kings were meant to be understood as myth, why weren't they presented in mythological language? Why use the bureaucratic format reserved for factual accounting? The numbers themselves reveal something remarkable when examined closely. Those seemingly impossible reign lengths aren't random. They're multiples of 3,600, a number that appears throughout Sumerian mathematics and astronomy. 43,200 is exactly 12 times 3,600. 36,000 is exactly 10 times 3,600. 28,800 is exactly 8 times. The pattern continues through the entire list. This number, 3,600, wasn't arbitrary to the Sumerians. It represented what they called a sar, a complete cycle. Modern astronomy reveals that 3,600 years is remarkably close to half the precessional cycle of certain celestial bodies, the time it takes for specific stellar configurations to return to similar positions in the sky. What if these numbers aren't recording individual human lifespans at all? What if they're recording something else entirely? Dynastic periods, astronomical cycles, or compressed historical memory that uses celestial mathematics as a mnemonic device. Ancient cultures often encoded historical information in astronomical terms because celestial cycles were the most reliable way to mark vast stretches of time. Without radiocarbon dating or written calendars spanning millennia, how else would you preserve the knowledge that something happened a very long time ago? You would anchor it to the stars, to cycles that repeat with mathematical precision, to patterns that could be recalculated and verified by anyone with the knowledge to observe the heavens. The King List wasn't unique. Multiple copies of it have been found, inscribed on different tablets from different periods, but all maintaining the same core information about the pre-flood rulers. This indicates that the text was considered important enough to be copied and preserved across generations. It was part of the official historical record, maintained by scribes who understood its significance. Among these copies, the most complete is the Weld Blundell prism, a clay object slightly larger than a wine bottle, inscribed on all four sides with the complete list of kings, from the mythical past through the historical dynasties. The scribe who created it, a man named Nur-Ninsubur, dated his work to the reign of King Utu-Hegel of Uruk, around 2100 BCE. He wasn't creating fiction. He was preserving what he believed to be the historical record of human governance. The text describes something else that demands attention. The cities where these pre-flood kings ruled: Eridug, Bad Tibira, Larag, Zimbir, Shurupag. Archaeological excavations have confirmed that all these cities existed and that they show evidence of habitation in the very earliest periods of Sumerian civilization. Some of these sites contain occupation layers that extend far deeper than the dynastic periods, with settlement remains buried under many meters of sediment. At Shurupag, excavations revealed a dramatic flood layer, a thick deposit of water-laid clay that separates earlier occupation levels from later ones. Similar flood deposits appear at multiple Mesopotamian sites, dated to roughly the same period around 2900 BCE. The geological evidence confirms what the King List claims. There was a catastrophic inundation that disrupted civilization in this region. But here's what the standard interpretation struggles to explain. If the pre-flood kings are pure mythology, why did the Sumerians go to such lengths to maintain precise numerical records of their reigns? Why preserve specific cities, specific sequences, specific multiples of astronomical cycles? Mythology doesn't require that level of bureaucratic detail. Epic poems don't need accounting precision. The simplest explanation is that the King List represents an attempt to preserve genuine historical memory, compressed and encoded in the only framework available to a post-catastrophe society: the mathematics of celestial cycles and the administrative language of temple bureaucracy. Consider what this means. If the pre-flood section of the King List represents real history, translated into astronomical timekeeping, then it suggests something profound: that organized governance, city-states, and centralized authority existed in Mesopotamia long before the date we assign to the beginning of Sumerian civilization. It suggests that when Uruk emerged as a major city around 3200 BCE, it wasn't inventing kingship, it was restoring it. The rulers of early Sumer weren't pioneering a new form of social organization. They were rebuilding one that had existed before, one that had been destroyed by the deluge and nearly forgotten in the chaos that followed. The Sumerian texts themselves seem aware of this. They refer repeatedly to knowledge being restored, to divine wisdom being passed down from before the flood. To the pre-diluvian sage kings called the Apkallu, who brought civilization to humanity. These beings are described not as gods, but as teachers, culture heroes who possessed advanced knowledge and shared it with survivors. In Sumerian cosmology, there were 7 primary Apkallu, and they're credited with establishing the foundations of civilization: agriculture, architecture, astronomy, writing, mathematics, and law. Every major achievement of Sumerian society is attributed not to Sumerian invention, but to instruction received from these pre-flood figures. The text doesn't ask us to worship these beings. It asks us to remember them. It preserves their names, their cities, their teaching, encoded in numbers that ensure the information can survive even if the full context is lost. The King List is a message across time, a desperate attempt by survivors of a catastrophe to preserve the memory that they weren't the first, that something came before, something sophisticated enough to have kings and cities and knowledge worth preserving. The astronomical numbers aren't exaggerations, they're calendars, encoded chronologies marking periods of time so vast that only celestial mathematics could measure them accurately. The clay records what words could not, that human civilization is far older than we've been willing to admit, and that the flood wasn't a myth. It was history's reset button. And we're still living in its aftermath. Stand before the Great Sphinx of Giza and look closely at its weathered limestone body. The official narrative tells you that this monument was carved during the reign of Pharaoh Khafra around 2500 BCE, part of the 4th dynasty building program that included the second pyramid on the plateau. The story is neat, contained, accepted by mainstream Egyptology without significant controversy. But the stone itself tells a different story, one that challenges not just the dating of a single monument, but our entire understanding of when advanced civilization emerged in the Nile Valley. The Sphinx bears scars that shouldn't exist if the conventional timeline is correct. These are erosion patterns carved not by wind and sand, but by water. Heavy, sustained rainfall. The kind of precipitation that hasn't occurred on the Giza Plateau in over 9,000 years. In 1990, a geologist named Robert Schoch from Boston University was invited to examine the Sphinx from a geological rather than archaeological perspective. What he found was unambiguous. The deep vertical fissures and undulating horizontal weathering patterns on the Sphinx's body and the walls of its enclosure are textbook examples of precipitation-induced erosion. When stone is weathered by wind and sand, it creates sharp, horizontal striations and undercuts the softer layers while leaving the harder layers protruding. But the Sphinx shows the opposite pattern: rounded, flowing profiles characteristic of water runoff and subsurface water infiltration. The limestone has been carved by rain, by water flowing down its surfaces and pooling around its base for extended periods. This type of weathering requires centuries of exposure to a climate far wetter than anything Egypt has experienced in recorded history. The surrounding enclosure walls show the same erosion profile, deepening the mystery. These walls were cut from the same bedrock when the Sphinx was carved, meaning they've been exposed to the elements for exactly the same duration. If wind erosion were responsible, we would expect the walls facing the prevailing winds to show more wear. Instead, the erosion is uniform, vertical, and consistent with water damage across all surfaces, regardless of orientation. Geologists who study erosion patterns can distinguish between different weathering agents with high confidence. The patterns on the Sphinx are not ambiguous. They're the result of sustained exposure to rainfall, not the occasional desert storms that modern Egypt experiences, but the kind of consistent, heavy precipitation associated with a fundamentally different climate regime. Egypt's climate history is well documented through multiple lines of evidence. Paleoclimatological studies using sediment cores, pollen analysis, and geological surveys all confirm that the Sahara region experienced a dramatic shift from a relatively humid environment to an arid desert. This transition occurred gradually between 10,000 and 5,000 BCE, with the most intense period of rainfall ending around 9,500 BCE. During this earlier wet phase, the Sahara wasn't a desert at all. It was a landscape of grasslands, lakes, and seasonal rivers. Crocodiles and hippos lived in what are now sand dunes. Human settlements clustered around water sources that no longer exist. The archaeological evidence for this wet period is undeniable. Preserved in rock art showing animals and vegetation that require substantial rainfall to survive. If the Sphinx shows water erosion, and that level of rainfall hasn't occurred at Giza since around 9,500 BCE, then the monument must have been carved before that date. This pushes its construction back at least 7,000 years earlier than the conventional timeline, placing it in a period when Egypt supposedly had no cities, no monumental architecture, and no organized state capable of undertaking such a massive project. The implications are staggering. Either our understanding of when civilization emerged in Egypt is fundamentally wrong, or the Sphinx is evidence of a sophisticated culture that existed during the wet Sahara period and then vanished as the climate changed, leaving behind monuments that later dynasties claimed as their own. The response from mainstream Egyptology to this geological evidence has been dismissive, but the counter-arguments don't hold up under scrutiny. Some scholars have suggested that the erosion could have been caused by the Nile flooding or groundwater seepage. But the Sphinx sits well above the floodplain, and groundwater erosion produces different patterns, typically affecting lower portions of structures more severely, and creating mineral deposits and salt crystallization that aren't present on the Sphinx. Others have argued that the weathering could result from chemical processes or industrial pollution from modern Cairo. Yet these explanations can't account for the identical erosion patterns found deep within the Sphinx enclosure, on walls that have been buried under sand for most of recorded history, protected from modern pollutants and contemporary weather conditions. What makes the water erosion evidence even more compelling is what surrounds the Sphinx. The temples at its base, the Valley Temple and the Sphinx Temple, are constructed from massive limestone blocks weighing up to 200 tons each. These blocks show the same precipitation-induced weathering on their lower courses, the sections that were quarried from the Sphinx enclosure itself and placed immediately after the monument was carved. But the upper courses of these temples, added later using different stone, show only wind erosion and the sharp weathering patterns consistent with the current desert climate. This creates a clear chronological marker, the lower sections exposed to the ancient rainfall, the upper sections built after the climate had shifted to arid conditions. The Egyptian authorities possess an artifact that might resolve this controversy, but it remains largely inaccessible to independent researchers. The inventory, stela, discovered in the 1800s near the Great Pyramid, contains an inscription that attributes the construction of the Sphinx to a period long before Khafre. The text describes how Khafre built a temple beside the Sphinx and repaired damage to the monument caused by lightning, explicitly stating that the Sphinx already existed during his reign. If authentic, this inscription confirms that 4th dynasty pharaohs weren't the original builders, but rather the restorers of monuments that were already ancient in their time. Egyptologists dispute the stela's reliability, arguing it was created during the much later 26th dynasty. But even if that's true, it demonstrates that Egyptians of the 1st millennium BCE believed the Sphinx predated the Pyramid Age. The conventional timeline creates another problem: construction sequence. If Khafre's builders carved the Sphinx, they would have quarried enormous quantities of limestone in the process. Yet there's no evidence that this stone was used in Khafre's pyramid. The pyramid was built primarily using different types of limestone quarried from other locations on the plateau. Where did the Sphinx quarry stone go? The most logical answer is that it was used to build the temples at the Sphinx's base, but those temples are architecturally distinct from 4th dynasty construction. They used the megalithic approach found in the most ancient structures, massive blocks fitted with minimal mortar, rather than the smaller, more regular blocks characteristic of pyramid construction. The geology doesn't lie. Stone records its environmental history with precision that no human revisionism can alter. The Sphinx was carved when Egypt was wet. It stood through millennia of rainfall. It witnessed the slow transformation of grassland into desert. And when the first pharaohs rose to power in the Nile Valley around 3000 BCE, the monument was already ancient, its origins forgotten or deliberately obscured. The dynasties that followed didn't build the Sphinx. They inherited it, maintained it, and eventually claimed it as their own. The water erosion is evidence of something that mainstream archaeology cannot accommodate, without dismantling fundamental assumptions about when and how civilization emerged. So instead, the evidence is ignored, explained away, or dismissed as anomalous. But the stone remains, weathered by rains that fell when the world was different, bearing witness to a chapter of human history that we've chosen to forget. The Great Pyramid of Giza is not simply large. Large would be impressive enough. Large would demonstrate organizational capacity, labor mobilization, and engineering ambition. But the Great Pyramid is something else entirely. It's precise, mathematically, geometrically, astronomically precise in ways that shouldn't be possible for a civilization working with copper tools, wooden sledges, and rope. The tolerances are too tight. The measurements are too exact. The alignments are too perfect. When you examine the structure not as a tomb or a monument, but as a mathematical object, as an encoded message written in stone, what emerges is undeniable. Whoever built this structure possessed knowledge of the Earth's dimensions and celestial mechanics that Orthodox history claims wasn't available until the age of satellite technology. Consider the base of the pyramid. Each of the 4 sides measures approximately 230 meters, and they're equal to within a few centimeters. This might not sound remarkable until you understand what it required. The base covers 13 acres of desert plateau, and the builders managed to level this foundation to within 2 centimeters across the entire area. Modern construction projects struggle to achieve such precision even with laser levels and computer-guided surveying equipment. The pyramid builders accomplished it using tools that, according to mainstream archaeology, were primitive by comparison. They didn't just level the ground roughly. They created a foundation so flat, so precisely horizontal, that modern engineers studying the structure have expressed disbelief at the achievement. The precision extends to the orientation. Each side of the pyramid faces one of the cardinal directions with extraordinary accuracy. The north face aligns with true north to within 3 arc minutes, a deviation so small that it wasn't definitively measured until the 19th century when precision surveying instruments became available. This alignment isn't approximate or close enough for practical purposes. It's exact within the limits of measurement error. To achieve this, the builders needed to understand the difference between magnetic north and true north, required sophisticated astronomical observation to determine the polar axis, and possessed surveying techniques capable of translating celestial observations into ground-level construction with minimal error propagation. But the real mystery emerges when you examine the pyramid's dimensions in relation to the Earth itself. The structure's height, when multiplied by 43,200, gives you the polar radius of the Earth to within a fraction of a percent. The perimeter of the base, when multiplied by the same factor, approximates the equatorial circumference of the planet with similar accuracy. This factor, 43,200, isn't arbitrary. It appears in Sumerian astronomical texts as a significant cycle period. The builders embedded planetary measurements into the monument's architecture using a scaling factor derived from ancient Mesopotamian mathematics. This wasn't coincidence. This was intentional encoding. The pyramid's angle of slope, approximately 51 degrees and 51 minutes, produces another remarkable mathematical relationship. This specific angle creates a ratio between the pyramid's height and its base perimeter that equals the ratio between a circle's radius and its circumference. In other words, the pyramid's dimensions encode the value of pi to several decimal places. But here's what makes this unsettling. Pi, as a mathematical constant, wasn't formally described until Greek mathematicians began studying it over 2,000 years after the pyramid's supposed construction date. How did Bronze Age builders incorporate a transcendental number into their architectural design without understanding the mathematics that define it? The internal structure reveals even deeper precision. The king's chamber sits at a specific height within the pyramid, 1/3 of the total height from the ground to the apex when measured along the pyramid's sloped face. The chamber itself displays construction tolerances that modern masons find difficult to replicate. The granite blocks that form the walls are fitted together with gaps measuring less than 0.5 millimeter. The chamber's dimensions follow specific mathematical ratios. The length is exactly twice the width, and the height equals the diagonal of a floor plan rectangle. These aren't round numbers or approximations. They're precise ratios that suggest intentional geometric design based on sophisticated mathematical understanding. The so-called air shafts extending from the king's chamber present another mystery. For decades they were thought to be ventilation ducts, but their angles reveal something else. When projected outward, these shafts align with specific stars, as they would have appeared in the night sky around 10,500 BCE. The southern shaft points toward Alnitak, the brightest star in Orion's belt, while the northern shaft targets Alpha Draconis in the constellation Draco. These alignments aren't approximate. They're calculated with astronomical precision to target these stars at their culmination points. Why would pyramid builders encode stellar positions from thousands of years before the monument's supposed construction date, unless they were preserving knowledge from an earlier epoch? The construction technique itself defies explanation. The pyramid contains approximately 2,300,000 stone blocks, each weighing between 2 and 15 tons. The heaviest stones in the king's chamber above weigh 50 to 80 tons and were somehow lifted to a height of 43 meters. The accepted narrative suggests ramps, levers, and vast numbers of laborers pulling these blocks into position. But engineering analysis reveals problems with this explanation. A ramp capable of reaching the pyramid's upper levels would need to be longer than the pyramid itself and contain more material than the structure. Internal ramps create structural problems and leave no archaeological evidence. The logistics of moving this much stone with the proposed methods would require impossibly high transportation rates maintained over decades. The acoustic properties of the king's chamber add another layer of mystery. The chamber resonates at a frequency of approximately 110 Hz, corresponding to a low F-sharp on the musical scale. This frequency isn't random. It matches the resonant frequency that many ancient structures around the world seem designed to produce or amplify. The granite blocks that form the chamber are positioned to create standing waves at this specific frequency. Why would tomb builders concern themselves with acoustic engineering unless the chamber served a purpose beyond simple burial? The precision required to tune a stone chamber to a specific frequency suggests knowledge of harmonics and wave mechanics that shouldn't exist in Bronze Age Egypt. Modern attempts to replicate even small portions of the pyramid's construction have failed to match the precision of the original. In 1997, a Japanese team attempted to build a small-scale pyramid using ancient techniques as described by Egyptologists. They couldn't achieve the accuracy of fit between stones. They couldn't level the foundation to the same tolerance. They couldn't align the structure with comparable precision. Even with modern knowledge informing their attempt, even with the advantage of studying the original, they fell short. This suggests that either our understanding of ancient Egyptian technology is incomplete, or the pyramid builders possess techniques and knowledge that haven't been preserved in the historical record. The astronomical alignments extend beyond the shafts. The 3 pyramids of Giza, when viewed from above, mirror the pattern of the 3 stars in Orion's belt with remarkable accuracy. The relative sizes, positions, and even the slight offset of the 3rd pyramid match the stellar configuration. The Nile River's position relative to the pyramids corresponds to the Milky Way's position relative to Orion. This correlation between terrestrial monuments and celestial patterns is called the Orion correlation theory, and while debated, the mathematical correspondence is difficult to dismiss as coincidence. The builders created a terrestrial map of the heavens, freezing a specific stellar configuration in stone. The evidence accumulates into an unavoidable conclusion. The Great Pyramid wasn't built by a civilization stumbling toward architectural understanding. It was built by architects who possessed advanced knowledge of mathematics, astronomy, and planetary dimensions. They understood pi before it was formally defined. They knew the Earth's measurements before global exploration. They aligned structures with stellar positions from millennia in the past. This knowledge had to come from somewhere. It had to be learned, developed, refined, and preserved across generations. The pyramid itself may have been built during the 4th dynasty, but the knowledge required to design it predates that dynasty by thousands of years. The structure isn't evidence of Egyptian innovation. It's evidence of Egyptian inheritance. the application of blueprints handed down from predecessors whose own monuments have vanished or remain unrecognized beneath desert sands and rising seas. There exists a story that humanity tells itself across every inhabited continent, in languages that share no common root among peoples separated by vast oceans and millennia of isolation. It's the story of the flood, the deluge, the great inundation that destroyed the world and forced humanity to begin again. More than 500 distinct cultures preserve some version of this narrative, and while the details vary, the core elements remain remarkably consistent: rising waters that cover the land, the survival of a remnant population, the loss of the previous world, and the beginning of the current age. Mainstream scholarship treats these stories as independent mythological developments, symbolic narratives that reflect universal human anxieties about water and chaos. But that explanation requires us to ignore something deeply unsettling. The stories aren't just similar in theme, they're similar in specific detail, describing the same sequence of events, the same duration of catastrophe, the same aftermath of devastation. The Mesopotamian epic of Gilgamesh contains one of the oldest written flood accounts, recorded on clay tablets that predate the biblical narrative by over 1,000 years. In this text, the god Ea warns the sage Utnapishtim of an impending deluge and instructs him to build a massive boat, seal it with pitch, and bring aboard representatives of all living creatures. The flood comes, covering even the mountains, lasting for 6 days and 7 nights before the waters recede. Utnapishtim sends out birds to test whether dry land has emerged, releasing first a dove, then a swallow, and finally a raven that doesn't return. The details are specific, sequential, and precisely described. This isn't a vague metaphor about divine anger. This is an account that reads like eyewitness testimony, preserved across centuries through oral tradition before being committed to clay. The biblical account in Genesis follows the same narrative structure with remarkable fidelity. Noah receives warning of the flood, builds an ark according to specific dimensions, brings animals aboard, and survives an inundation that covers the highest mountains. The duration differs slightly: 40 days and 40 nights of rain, followed by months of gradually receding waters. But the sequence of events, the bird releases, the landing on a mountain, the covenant marking the end of destruction and the beginning of renewal, all mirror the Mesopotamian account so closely that scholars agree the stories share a common origin. The question isn't whether they're related. The question is what event they're describing. Move halfway around the world to the Americas, to cultures that had no contact with Mesopotamia or the ancient Near East, and you find the same story. The Aztec tradition speaks of Nahui Atl, the age of water, when the sky collapsed and the world was flooded. Only those who transformed into fish survived. The Mayan Popol Vuh describes how the gods destroyed the first creation with a great flood because humanity had become corrupted. The Inca preserved accounts of Unu Pachacuti, the water that overturns the world, a catastrophic flood sent by the god Viracocha that destroyed the previous race of giants. Among North American indigenous peoples, the flood narrative appears in dozens of distinct traditions. The Ojibwe speak of Nanabojo surviving a flood in a canoe. The Hopi describe emergence from a previous world destroyed by water. The Cheyenne recount how the Creator warned a righteous man to build a raft before the waters rose. Cross the Pacific to Australia, and the Aboriginal peoples maintain oral traditions describing a time when the seas rose and swallowed the coastal lands where their ancestors lived. These stories aren't vague or metaphorical. They describe specific geographic features now underwater, ancient coastlines that existed only during the last ice age, when sea levels were over 100 meters lower than today. The traditions speak of people fleeing inland as the waters advanced, of valleys becoming bays, of hunting grounds disappearing beneath the waves. Geological surveys have confirmed that the features described in these oral traditions actually exist underwater off the Australian coast, validating what mainstream academics had dismissed as mythology. In India, the Matsya Purana tells of Manu, warned by a fish avatar of Vishnu about an impending deluge that would destroy all living creatures. Manu builds a boat and survives the flood that submerges the entire world. The Bhagavata Purana provides even more detail, describing how the waters rose gradually at first, then catastrophically, covering mountains and leaving only the peaks of the highest ranges visible above the surface. The account emphasizes the total of the destruction and the preservation of sacred knowledge through the catastrophe. In Buddhist tradition, the Jatakas reference multiple world-ending floods as part of the cosmic cycle of destruction and renewal. The Greek tradition preserves the story of Deucalion, who survived a flood sent by Zeus to destroy the degenerate Bronze Age of humanity. Warned by his father Prometheus, Deucalion built a chest, stocked it with provisions, and rode out 9 days and nights of rain that submerged all but the highest peaks. When the waters receded, he and his wife Pyrrha repopulated the earth. The Roman poet Ovid recorded this account in his Metamorphoses, treating it not as myth, but as history, part of the succession of ages through which humanity had passed. The Norse tradition speaks of a deluge of blood from the giant Ymir that drowned all but 2 humans who survived to restart the human race. What makes these parallel accounts impossible to dismiss as coincidence is their specificity. They don't just say, there was a flood. They describe the same pattern: a warning period, a chosen survivor or family, the construction of a vessel, the gathering of animals or provisions, rising waters that cover mountains, a duration of weeks to months, the gradual recession, the landing on elevated terrain, the release of birds to scout for dry land, and the covenant or promise marking a new beginning. These aren't universal archetypes emerging independently. These are variations of a core narrative, altered by time and cultural transmission, but preserving the essential sequence of a real event. The geological evidence validates what the myths preserve. Around 11,600 years ago, at the end of the last ice age, the planet experienced rapid and catastrophic climate change. Ice cores from Greenland show temperature increases of 15 degrees Celsius occurring within decades, possibly within a single decade. This warming triggered the collapse of massive ice sheets covering North America and Eurasia. The resulting meltwater poured into the oceans, raising sea levels by approximately 120 meters over the course of several thousand years. But the rise wasn't gradual. It came in pulses, sudden surges when ice dams failed and released enormous volumes of water in geological instants. The underwater archaeology supports this timeline. Submerged coastal settlements have been discovered off the coasts of India, Japan, the Mediterranean, and the Caribbean. Structures that were built on dry land and then inundated as the seas rose. The dating of these sites corresponds to the end of the last ice age, the period when global sea levels were rising most rapidly. What we call mythology is actually compressed historical memory, oral traditions preserving the experience of populations who watched their world disappear beneath the waves. The stories aren't symbolic, they're testimonies, accounts of survival passed down through generations until someone finally wrote them on clay or papyrus or skin. The flood narratives also preserve another crucial detail: the loss of knowledge. Nearly every tradition emphasizes that the pre-flood world was more advanced, that wisdom and civilization existed before the waters came and were lost in the catastrophe. The Sumerian King List marks the flood as the dividing line between the long-reigning antediluvian kings and the shorter-lived dynasties that followed. The biblical narrative describes the Nephilim, beings of great knowledge who existed before the deluge. The Hindu texts speak of advanced civilizations destroyed by water, their wisdom preserved only in fragments. This consistent theme suggests that the flood didn't just kill people. It reset civilization, destroying cities built on coastlines, drowning agricultural lands, and forcing survivors to start over with incomplete knowledge. The myths are maps. They chart the contours of a catastrophe that shaped human development more profoundly than any other event in our species' history. They tell us that we've been here before, that we've built and lost and built again. The waters didn't just rise. They erased, covering evidence beneath sediment and salt, leaving only memory to bridge the gap between what was and what remains. The Sumerian language is an anomaly that linguists have struggled to explain for over a century. When scholars first deciphered cuneiform in the 1800s, they expected to find connections to other ancient languages, evolutionary relationships that would trace Sumerian back to earlier linguistic roots. That's how languages work. They develop from parent tongues, borrowing vocabulary, sharing grammatical structures, and maintaining recognizable connections to related languages. But Sumerian has no relatives. It's what linguists call an isolate, a language that appears in the historical record, fully formed with no known ancestors and no clear descendants. It simply exists, already sophisticated, already capable of expressing complex legal concepts, astronomical observations, and mathematical operations. The question isn't just where the language came from. The question is what knowledge it was designed to preserve. The structure of Sumerian itself suggests advanced linguistic engineering. It's an agglutinative language, meaning it builds words by combining smaller units of meaning in systematic ways. This allows for precise expression of complex ideas through predictable grammatical patterns. But what makes Sumerian remarkable is its technical vocabulary, the specialized terminology that appears in the earliest texts without any evidence of gradual development. The language contains specific words for astronomical phenomena that required centuries of observation to identify: planetary retrograde motion, lunar nodes, ecliptic coordinates, and precessional cycles. These aren't poetic metaphors or vague celestial references. They're technical terms with precise meanings, the vocabulary of systematic scientific observation. The cuneiform tablets preserve lists of Sumerian words organized by semantic category, early dictionaries created by scribes to teach the language and preserve its vocabulary. Among these lexical texts are sections dedicated to astronomical terminology, and the precision is striking. There are distinct words for different types of celestial events: lunar eclipses versus solar eclipses, conjunctions of specific planets, the heliacal rising of particular stars. The language distinguishes between apparent motion and true motion of celestial bodies, suggesting an understanding that what we see in the sky doesn't always reflect underlying physical reality. This level of astronomical sophistication requires not just observation, but theoretical understanding. The ability to model celestial mechanics and predict future events based on mathematical calculation. The religious texts add another layer of mystery. The Sumerian pantheon includes the Anunnaki, beings described in tablets as those who came from heaven to earth. Mainstream interpretation treats these as gods, mythological figures representing natural forces or social hierarchies. But the texts don't describe them mythologically. They describe them clinically, with the same matter-of-fact tone used for legal proceedings and administrative records. The Anunnaki are credited with specific technological achievements: the establishment of irrigation systems, the introduction of metallurgy, the teaching of mathematics and writing, the organization of urban planning. They're described as instructors, not as distant deities to be worshipped, but as present beings who interacted directly with humanity and transferred knowledge. One text, the Eridu Genesis, provides an account that parallels the biblical creation narrative, but with crucial differences in detail. It describes how the Anunnaki established the first cities before humanity had organized into civilizations, how they created agricultural systems and taught farming techniques, how they transferred the knowledge of kingship and governance. The text explicitly states that civilization didn't develop organically from human innovation. It was taught, given, transferred from those who already possessed it to those who needed to rebuild after catastrophe. The language used isn't metaphorical, it's instructional, describing a deliberate process of cultural transmission from an advanced source to a recovering population. The term Anunnaki itself carries linguistic significance. It breaks down into component meanings: Anu, the sky or heavens, and Ki, the earth, connected by the particle na. The term literally means those of heaven and earth, beings associated with both celestial knowledge and terrestrial presence. But the texts go further, describing them with numbers: 50 who descended, 7 who judged, 12 who governed. These aren't symbolic numbers. They appear consistently across multiple texts, suggesting specific individuals or groups rather than abstract concepts. The mathematical precision of the descriptions implies that the Anunnaki were historical figures whose deeds were recorded with the same bureaucratic accuracy applied to grain inventories and land surveys. The Atrahasis epic, another key Sumerian text, describes how the Anunnaki grew weary of laboring on Earth and created humans to perform agricultural work. The account reads less like mythology and more like a description of genetic engineering. The mixing of clay with the essence of a god, the careful preparation, the repetition of the process to create multiple humans. The text specifies that the goddess Nintu created 7 males and 7 females, establishing population diversity from the beginning. Modern readers interpret this as creation myth, but the clinical detail and procedural specificity suggest the text is attempting to describe a technological process using the only vocabulary available to Bronze Age scribes. What makes the Sumerian accounts particularly significant is their consistency across thousands of tablets. The stories don't change substantially from text to text. The same names appear, the same sequences of events, the same relationships between beings and humans. This consistency suggests the accounts are based on a fixed corpus of knowledge, possibly older texts that were being copied and preserved, rather than new compositions being invented. The scribes who wrote these tablets weren't creating mythology. They were maintaining an archive, preserving information they considered historically significant even if they no longer fully understood its original context. The language contains another telling feature: technical vocabulary for catastrophic events. There are specific Sumerian words for cosmic impacts, for objects falling from the sky, for celestial disturbances that threaten the Earth. The vocabulary isn't limited to natural disasters like floods or earthquakes. It describes phenomena that require astronomical knowledge to identify: meteor swarms, cometary debris, celestial alignments that presage catastrophe. This specialized terminology suggests the Sumerians, or those who came before them, had experience with cosmic threats and developed language to describe and predict them. The words aren't poetic descriptions of divine anger. They're technical terms for physical phenomena. The transmission of Sumerian reveals another mystery. After Sumerian ceased to be a spoken language around 2000 BCE, it remained in use as a scholarly and liturgical language for another 1500 years. Scribes in Babylon and Assyria continued to copy Sumerian texts, study Sumerian grammar, and maintain Sumerian vocabulary lists long after anyone spoke the language natively. Why preserve a dead language with such dedication? Because the texts written in Sumerian were considered irreplaceable repositories of knowledge, wisdom that couldn't be allowed to disappear even as the civilization that created them collapsed. The language was maintained not for communication, but for preservation, to keep alive information that had already survived one catastrophe and couldn't be allowed to vanish in another. The clay tablets themselves become significant when you consider their durability. Unlike papyrus or parchment that decays, unlike oral traditions that shift with each retelling, clay preserves information with near permanence. Once inscribed and baked, a tablet becomes essentially indestructible by anything short of deliberate crushing. Water doesn't harm it. Fire actually strengthens it. Time barely affects it. The Sumerians chose the most durable medium available to preserve their most important knowledge. They weren't writing for their contemporaries alone. They were writing for us, for whoever would eventually dig beneath the sand and decode their messages. The language of the gods wasn't divine speech. It was the vocabulary of inheritance, technical knowledge encoded in grammatical structures, preserved across millennia in characters pressed into clay, by hands that remembered when the world had been different, when the knowledge had been common, when someone still understood what the words truly meant. There are stones scattered across this planet that shouldn't exist where they are, not because they're impossible to quarry or transport in absolute terms, but because the civilizations credited with moving them supposedly lacked the technology, the organizational capacity, and the engineering knowledge required to accomplish such feats. Yet, the stones are there, fitted together with tolerances measured in millimeters, aligned with celestial precision, displaying construction techniques so sophisticated that modern engineers struggle to replicate them even with contemporary equipment. What makes this mystery unsolvable within conventional historical frameworks isn't just the achievement of individual sites. It's the repetition of identical techniques across continents, among cultures separated by vast oceans and thousands of years, all employing the same architectural philosophy as if following instructions from a common source. Consider Sacsayhuaman, the fortress complex overlooking Cusco in Peru. The walls are constructed from limestone blocks weighing up to 200 tons each, cut and shaped with such precision that the joints between stones require no mortar. The blocks aren't rectangular. They're polygonal, each one a unique shape that interlocks with its neighbors in 3 dimensions, creating a jigsaw puzzle of stone that has survived earthquakes, which leveled Spanish colonial buildings constructed centuries later. The Spanish conquistadors who first saw these walls couldn't believe the Inca had built them. They attributed the construction to demons or giants, unable to conceive how humans with stone and bronze tools could shape such massive blocks into such complex forms and lift them into position. The official narrative claims the Inca built Sacsayhuaman in the 15th century using tens of thousands of workers pulling the blocks on log rollers. But this explanation creates immediate problems. The site sits at an elevation of over 3,600 meters, well above the tree line. There were no forests to provide log rollers. The nearest quarry for the larger stones is over 35 kilometers away across mountainous terrain. Moving a 200-ton block even 1 kilometer on flat ground would require extraordinary engineering. Moving it 35 kilometers through mountains would require technology that the Inca, by all orthodox accounts, didn't possess. Yet the stones are there, fitted so precisely that you cannot slide a knife blade between them. Positioned with such stability that they've remained in place through 5 centuries of seismic activity. Cross the Pacific Ocean to Baalbek in modern Lebanon, and you encounter the same impossibility. The Roman Temple of Jupiter sits atop a platform constructed from stones weighing up to 1,000 tons. These aren't the relatively manageable blocks of Roman construction visible in the temple above. These are megalithic foundations, remnants of an earlier structure that the Romans built upon but didn't create. The larger stones, known as the trilithon, each weigh approximately 800 tons and are positioned 20 meters above ground level. Roman engineering, sophisticated as it was, has left us detailed records of construction techniques, diagrams of lifting machines, accounts of labor organization. None of these methods could move 800-ton blocks. The largest stones the Romans typically worked with weighed 50 to 100 tons, and moving those required massive effort and specialized equipment. The quarry for the Baalbek stones still contains an even larger block, the stone of the pregnant woman, weighing over 1,000 tons and partially cut from the bedrock. It lies there as if abandoned mid-project, raising questions that conventional archaeology struggles to answer. Who began cutting this stone? What technology did they plan to use to move it? Why was the work abandoned? The Roman historian Pliny the Elder, writing in the 1st century CE, described the foundation stones at Baalbek as a miracle of, suggesting that even in antiquity, people didn't understand how they had been placed there. The Romans built their temple on top of these foundations because the megaliths were already there, already ancient, already beyond the capability of imperial Rome to replicate. Move to Easter Island, one of the most isolated inhabited places on Earth, and the pattern repeats. The Moai statues, carved from volcanic tuff, weigh up to 82 tons. Nearly 900 of them dot the island, most still standing on stone platforms called ahu. The carving itself demonstrates remarkable skill, but the transportation and positioning of these massive figures present the real mystery. The island population, by archaeological estimates, never exceeded 15,000 people and likely numbered far fewer during the main statue-building period. How did a small population with limited resources move hundreds of massive statues across several kilometers of rough terrain and then raise them upright on platforms with precision? The conventional explanation involves ropes, logs, and coordinated teams of workers rocking the statues forward in an upright walking motion. Experimental archaeology has demonstrated this method can work for smaller moai, but the larger statues present insurmountable problems. The effort required increases exponentially with size, and the island's limited timber resources couldn't support the construction of adequate transport infrastructure for the heaviest moai. Yet they were moved, positioned, and topped with separate red stone cylinders called pukao, some weighing over 10 tons, lifted to heights of 10 meters, and balanced atop the statues. The engineering precision required to accomplish this, without damaging the statues or the platform, suggests sophisticated knowledge of leverage, balance, and structural mechanics. The architectural similarities across these sites, despite their geographic and temporal separation, suggest something more than parallel development. At Tiwanaku in Bolivia, at Ollantaytambo in Peru, at Menkaura's pyramid in Egypt, At the dolmen sites across Europe, you find the same construction approach. Massive stones fitted together with minimal gaps, shaped to interlock in complex three-dimensional patterns, positioned with astronomical alignments and showing evidence of advanced planning and engineering knowledge. The technique is consistent enough that archaeologists have noted the similarities, but struggle to explain them without proposing either improbable levels of cultural contact or independent invention of identical complex technologies multiple times across vastly different societies. The tool marks on these megalithic structures add another layer of mystery. Modern stone carvers examining sites like Pumapunku in Bolivia and Aswan in Egypt have identified precision cutting marks that suggest the use of diamond-tipped saws or advanced abrasive techniques. The granite blocks at Pumapunku show perfectly flat surfaces, precise right angles, and complex interlocking joints that would challenge contemporary stone-working facilities. Some blocks display H-shaped cuts and channels carved with such accuracy that variations across a 2-meter surface don't exceed 1 millimeter. This isn't the work of copper chisels and stone hammers. This is evidence of technology that either hasn't been discovered in the archaeological record or wasn't preserved because it was made from materials that decayed over millennia. The astronomical alignments that these structures encode represent another form of shared knowledge. The pyramids of Giza align with Orion's belt. Stonehenge tracks solar and lunar cycles with precision that allows prediction of eclipses. The temples at Angkor Wat in Cambodia mirror the constellation Draco as it appeared around 10,500 BCE. The lines at Nazca point towards solstice positions. Teotihuacan in Mexico aligns its main thoroughfare with the setting of the Pleiades. These aren't coincidences or lucky alignments. They represent deliberate astronomical observation and mathematical calculation, the application of celestial knowledge to terrestrial construction. The civilizations that built these structures understood the mechanics of the heavens well enough to freeze specific stellar configurations in stone. What emerges from examining these sites as a collective rather than as isolated achievements is a pattern that conventional history cannot accommodate. The same techniques appear too consistently across too wide a distribution to be explained by independent invention. The same astronomical knowledge manifests too precisely in too many locations to be coincidental. The same engineering sophistication appears too suddenly in too many cultures without evidence of gradual technological development. The simplest explanation, the one that requires the fewest assumptions and accounts for the most evidence, is that these diverse cultures inherited their architectural and astronomical knowledge from a common source. They weren't inventing megalithic construction. They were applying techniques learned from predecessors whose own monuments have either vanished beneath the waves or remain unrecognized beneath accumulated sediment. The stones we study today aren't evidence of multiple separate architectural traditions. They're copies of blueprints handed down from an older, more sophisticated civilization that built the originals and then disappeared, leaving only instructions that its inheritors followed imperfectly, preserving the method even as they lost the full understanding of why the method worked. Your DNA is a historical document, a molecular archive that records every catastrophe, migration, and near-extinction event your ancestors survived. Every human alive today carries genetic markers that tell a story mainstream history struggles to explain. The story isn't written in bones or artifacts or crumbling texts. It's written in your chromosomes, in patterns of variation and mutation that genetic analysis can date with remarkable precision. What those patterns reveal is deeply unsettling. Humanity came within a genetic whisper of complete extinction roughly 70,000 years ago. And again, around 12,000 years ago. Our species was reduced to population numbers so small that all of modern humanity descends from a founding group that may have numbered only a few thousand individuals. The genetic evidence for this bottleneck is undeniable, but what caused it remains one of the most significant unsolved mysteries in human prehistory. The 70,000-year event shows up in mitochondrial DNA analysis as a dramatic reduction in genetic diversity. Mitochondrial DNA passes from mother to child unchanged, except for random mutations, making it an excellent molecular clock for tracking lineages across deep time. When geneticists compare human mitochondrial DNA to that of our closest primate relatives, they find something shocking. Humans have far less genetic variation despite having a much larger global population. Chimpanzees, with a total population of perhaps 300,000 across Africa, show more genetic diversity than the 8 billion humans currently alive. This inverse relationship between population size and genetic variation indicates that humans pass through an extreme population bottleneck that nearly eliminated all genetic lineages except for those carried by a tiny surviving group. The nuclear DNA tells the same story with additional disturbing details. By analyzing variations across the entire human genome, researchers can reconstruct population history and identify periods when breeding populations shrank dramatically. The data consistently points to a catastrophic collapse in human numbers roughly 70,000 years ago, coinciding with the Toba supervolcano eruption in Indonesia. This event released approximately 2,800 cubic kilometers of ash and volcanic material into the atmosphere, triggering a volcanic winter that may have lasted 6 to 10 years. Global temperatures dropped by several degrees, disrupting ecosystems worldwide and creating conditions that would have made survival extremely difficult for early human populations adapted to African and Asian environments. The genetic evidence suggests that only a few thousand humans survived this catastrophe, possibly restricted to small refugia in Africa, where conditions remained marginally habitable. But the 70,000-year bottleneck isn't the only collapse recorded in our DNA. More recent genetic studies have identified population reductions around 12,000 to 13,000 years ago, corresponding to the Younger Dryas climate event and the end of the last ice age. This bottleneck isn't as severe as the Toba event, but it's significant enough to leave clear markers in the genetic record across multiple continental populations. The timing aligns perfectly with the flood narratives preserved in oral traditions worldwide, and with the geological evidence for rapid climate change and catastrophic meltwater pulses. Something happened during this period that reduced human populations globally, not to near extinction levels, but enough to create measurable genetic signatures in the DNA of people from Europe, Asia, the Americas, and Oceania. The genetic data validates what mythology preserved. There was a worldwide catastrophe that disrupted human populations and forced survivors to rebuild. The mystery deepens when geneticists examine what they call ghost populations, genetic lineages that appear in modern human DNA but have no corresponding archaeological or fossil evidence. These ghost populations show up as anomalous patterns of variation that can only be explained by interbreeding with groups of humans for which we have no physical remains. Ancient DNA extracted from bones and teeth can identify known ancestral populations like Neanderthals and Denisovans, but the ghost populations represent something else. Human groups that contributed to our genetic makeup, but left no trace in the archaeological record. Where did they live? When did they exist? Why have we found no evidence of their material culture? The most parsimonious explanation is that these ghost populations lived in regions now underwater or buried beneath sediment, coastal dwellers whose settlements were submerged when sea levels rose at the end of the Ice Age. The Denisovan discovery itself demonstrates how much we don't know. Until 2008, had no idea this entire branch of the human family tree existed. A single fingerbone and a few teeth from a cave in Siberia revealed a population that interbred with modern humans and left genetic traces in contemporary Melanesians, Aboriginal Australians, and some Asian populations. The Denisovan genome has been fully sequenced, yet we have almost no archaeological context for these people. We don't know what their material culture looked like, how they organized their societies, or what technological capabilities they possessed. If an entire human population can leave almost no archaeological trace despite contributing significantly to modern human genetics, how many other groups have vanished completely from the physical record while their genes persist in our chromosomes? Genetic analysis also reveals patterns of ancient admixture that challenge conventional models of human migration and development. Modern Europeans carry DNA from at least 3 distinct ancestral populations: indigenous hunter-gatherers, Anatolian farmers who arrived around 8,000 years ago, and steppe pastoralists who migrated around 5,000 years ago. But the mixing ratios and timing create problems for simple replacement models. The indigenous hunter-gatherer contribution is larger than expected if farming populations simply replace them through demographic expansion. The persistence of hunter-gatherer DNA suggests either prolonged coexistence and interbreeding, or the preservation of hunter-gatherer populations in refugia that later re-expanded and mixed with agricultural societies. Either scenario implies more complex population dynamics than the standard narrative of agricultural populations overwhelming and replacing hunter-gatherers. The Americas present another genetic puzzle. The peopling of the New World is traditionally explained through migration across the Bering Land Bridge around 15,000 years ago, with populations spreading southward through ice-free corridors. But genetic analysis reveals anomalies that don't fit this model cleanly. Some Native American populations show genetic affinities with populations from Southeast Asia and Oceania that can't be explained through the Bering route alone. Ancient DNA from Paleo-American remains sometimes shows genetic profiles different from contemporary Native American populations, suggesting either population replacement or substantial genetic drift. The discovery of ancient DNA in South American remains dated to over 10,000 years old, has revealed genetic diversity that implies multiple migration waves or founding populations with more complex origins than a single Beringian source. Perhaps most intriguing are the genetic signals that suggest humans possessed significant population structure and diverse adaptations long before the bottlenecks. Analysis of archaic human genomes reveals that before the population collapses, human groups showed remarkable genetic diversity and regional adaptations. Some populations had evolved tolerance for high-altitude environments, others had developed resistance to specific diseases, and groups showed physiological adaptations to different dietary regimes. This diversity suggests that human populations before the catastrophes were numerous, widely distributed, and well adapted to diverse environmental niches. The bottlenecks didn't just reduce numbers. They erased the genetic legacy of entire adapted populations, leaving only the survivors' lineages to repopulate the world. The chromosome data carries another message: selection signatures indicating rapid adaptation in the aftermath of bottlenecks. Geneticists can identify regions of the genome that show evidence of recent strong selection, indicating traits that spread rapidly through populations because they conferred significant survival advantages. Many of these selection signatures date to the post-bottleneck recovery periods, suggesting that survivors faced new environmental challenges that favored specific genetic variants. The selection affected genes related to immune function, metabolism, cognitive development, and stress response. These patterns indicate that the catastrophes didn't just reduce population size. They fundamentally altered the selective pressures acting on human populations, accelerating evolutionary changes in the aftermath of near extinction. Your genes don't just record that the catastrophes happened. They record how surviving populations adapted to survive in the transformed world that followed. Every ancient text that survived long enough to be translated carries the same message, encoded in different languages and expressed through different mythologies, but fundamentally identical in its core warning. The message isn't about the glory of past civilizations or the triumph of human achievement. It's about fragility, about how quickly everything can be lost, about the terrifying ease with which knowledge accumulated over millennia can vanish in a single generation. The Sumerians knew this. The Egyptians understood it. Every culture that rose from the ashes of catastrophe carried forward the memory that they weren't the first, that others had built before them and lost everything. The warning they preserved wasn't just historical record, it was prophecy, a message sent forward to descendants who might face the same threats, the same choices, the same potential for total collapse. The concept appears across cultures with unsettling consistency. The Hindu texts describe cycles of creation and destruction, yugas that span hundreds of thousands of years, each ending in catastrophe that resets civilization. The Mayan long count calendar tracks vast spans of time punctuated by periods of upheaval and renewal. The Greek philosophers wrote of recurring ages of humanity, each destroyed by different means: flood, fire, earthquake, cosmic impact. The Norse Ragnarok describes a cyclical apocalypse after which the world regenerates and begins again. These aren't isolated mythologies developed independently. They're variations of a single underlying truth that ancient peoples understood from experience. Civilizations don't progress linearly. They rise, flourish, grow complacent, and then collapse when faced with challenges their sophistication cannot overcome. The archaeological record confirms what mythology preserves. At multiple points in human history, complex societies have disappeared almost overnight in geological terms. The Bronze Age collapse around 1200 BCE saw the simultaneous fall of the Hittite Empire, the Mycenaean kingdoms, the Kassite dynasty in Babylon, and multiple Levantine city-states. Within a span of perhaps 50 years, an interconnected network of civilizations that had maintained trade, diplomatic relations, and cultural exchange for centuries simply ceased to function. Cities were abandoned or destroyed. Writing systems were forgotten. Technological capabilities were lost. The survivors regressed to subsistence agriculture, and it took centuries for civilization to recover to previous levels of complexity. The causes remain debated, but the outcome is undeniable. Sophisticated societies are far more fragile than their inhabitants believe. The collapse wasn't total. Some knowledge was preserved, transmitted through the Dark Age by scribes and priests who maintained fragments of the older learning. But vast amounts were lost irretrievably. The Linear B script of Mycenaean Greece vanished completely, not deciphered until the mid-20th century. Hittite cuneiform disappeared for over 3,000 years. The administrative techniques, agricultural innovations, and metallurgical advances that characterized the Bronze Age had to be slowly rediscovered or reinvented by successor cultures who had only fragmentary records and oral traditions to guide them. What survived was preserved not through systematic archival efforts, but through accident, through texts copied for religious purposes that happened to contain historical information, through monuments built so solidly they couldn't be easily destroyed even when their meaning was forgotten. The mechanism of collapse follows predictable patterns. Complex societies become dependent on intricate networks of specialization, trade, and institutional knowledge. When those networks break down through climate change, resource depletion, warfare, or disease, the society cannot simply scale back to simpler forms. The specialized knowledge required to maintain the complex systems exists in the minds of experts who may die without passing on their expertise. The written records that preserve institutional memory may be stored in temples and palaces that burn during invasions. The infrastructure that enables communication and coordination may require maintenance that becomes impossible during crisis. Complexity itself becomes vulnerability, and societies optimized for one set of environmental and social conditions prove catastrophically fragile when those conditions change. Modern civilization faces these same vulnerabilities amplified by our unprecedented level of interconnection and specialization. The knowledge required to maintain our technological infrastructure exists in increasingly narrow domains. How many people understand the physics underlying nuclear power plant operation? How many can fabricate microprocessors or synthesize essential medications? How much of our scientific knowledge exists only in digital formats stored on servers that require constant power and maintenance? We've created a civilization where essential knowledge is preserved not in durable physical media, but in systems that would fail completely within days if the electrical grid collapsed. The ancient scribes who pressed their knowledge into clay tablets ensured that information would survive for millennia. We store our knowledge in formats that might not survive a single generation without continuous technological support. The threats we face aren't hypothetical. Climate change is altering global weather patterns faster than agricultural systems can adapt. Antibiotic resistance is eliminating our ability to control bacterial infections that were trivial to treat 50 years ago. Declining aquifers threaten water supplies for billions of people. Soil degradation is reducing agricultural productivity precisely when we need to feed larger populations. Nuclear arsenals remain ready for deployment, capable of destroying civilization in hours. The asteroid detection systems we've developed can identify some threats, but we have no proven capability to deflect an incoming object if one is discovered on a collision course. Any of these threats, or combinations of them, could trigger cascading failures across our interconnected global systems. The ancient warning isn't about whether catastrophe will come. It's about whether we'll be prepared when it does. Every previous civilization that collapsed believed itself secure, believed its institutions permanent, believed its knowledge safe. The Romans couldn't imagine their empire falling. The Maya didn't anticipate the drought that would empty their cities. The Bronze Age kingdoms thought their network of alliances and trade would endure. They were wrong, and their confidence in permanence contributed to their unpreparedness for change. We make the same mistake, assuming our technology makes us invulnerable, that our scientific knowledge guarantees our survival, that the complexity we've built will protect rather than doom us when systems begin to fail. What the ancients understood, what they tried desperately to preserve in their texts and monuments, is that memory is survival. The knowledge that catastrophe has happened before, that civilization has fallen and rebuilt, that humanity has faced near extinction and survived by the narrowest margins. That information is the most valuable resource and the easiest to lose. They built in stone because stone endures. They encoded knowledge in astronomical alignments because the stars don't change on human timescales. They preserved oral traditions through repetition and ritual because they understood that without active effort, information disappears within a single lifetime. The messages they left weren't for their own generation. They were for us. Warnings sent across millennia by people who knew what we seem to have forgotten, that everything we've built can be lost. The question isn't whether the cycle will repeat. The geological and historical evidence makes clear that catastrophic disruptions to human civilization occur with regularity on timescales of thousands of years. The question is whether we're prepared, whether we're humble enough to learn from the mistakes of our predecessors, whether we're wise enough to preserve knowledge in formats that will survive the next collapse. The ancients left us their warning carved in stone, pressed into clay, encoded in myth. They showed us what happens when civilization fails to prepare for catastrophe. The only question remaining is whether we're listening, or whether we'll join them as another cautionary tale told by survivors in a future age. Another civilization that believed itself permanent and discovered too late. That memory, not technology, is what separates survival from extinction.
If you enjoyed the video, hit the like button, subscribe, and activate notifications so you don't miss our next videos.